Hi, I am Dr. Manju Chiller, Assistant Professor Dayal Singh College, University of Delhi. I welcome you all to this episode of UGC ePathshala. In this episode, we are going to learn about hydrogeomorphology. In this episode of hydrogeomorphology, we will discuss about the concept of hydrogeomorphology along with history. Then, we will discuss the important fundamentals of hydrogeomorphology, application of remote sensing and GIS in the studies of hydrogeomorphology, and in the end we will discuss about the future of the new geographical science, that is hydrogeomorphology. Now let us start with the basic introduction of the concept of hydrogeomorphology. Resources are essential elements of sustainability of human beings. Among all the resources, water and land are among the most important resources. Hydrogeomorphology deals with both of these resources. Hydrogeomorphology is a new field in geosciences that has emerged to study the linkages between water processes and landforms. It is a combination of three different terms: hydro, which refers to water including both surface water and underground water; geo, which refers to the ground and the landforms; morphology, which refers to the surface characteristics of the landforms. Hydrogeomorphology studies the two major aspects. The first one is effects of moving water to the hill slopes, river and landscapes on geomorphic processes and geomorphic forms, and effects of geomorphic forms on the spatial and temporal distribution of shallow groundwater. So, hydrogeomorphology is an interdisciplinary science that studies the link between two important branches of geosciences, that is hydrology and geomorphology. Other than hydrology and geomorphology, the concept of hydrogeomorphology are also largely derived from different branches of geosciences like geology, remote sensing, climatology and natural hazards. To study hydrogeomorphology, it is important to understand the difference between three branches of geosciences, that is geomorphology, geology, hydrology and geomorphology. Hydrogeomorphology, geology, hydrology and geomorphology all are different branches of geosciences and covers different subject matter but often get confused. Geology is the branch of geosciences that studies material of the earth along with the processes that are working upon them. Hydrology studies the occurrence, distribution, movement and relations of water with all the aspects of environment it interacts with. Geomorphology is the subfield of geology and studies the structure, evolution of the surface of the earth. It deals with the origin and changing structure of Earth's landform. So now we are very much clear about the basic concepts of hydrogeomorphology. Let's now move to the history of hydrogeomorphology. If you look at the history, in 1973, Shedagal used the term hydrogeomorphology for the first time in a science article under the Journal of Hydrology. He defined hydrogeomorphology as the study of shapes caused by water activities. He considered water as the most important shaping agent of the landforms. In 1988, Richards used this term again after the gap of 15 years to emphasize on the role of hydrogeomorphological studies in understanding the production scenarios of the river evolution at the hydrological basin scale. Okonishi also made a research on the term hydrogeomorphology in the year 1994, which further strengthened the growth of hydrogeomorphological studies as an important branch of geosciences. He defined hydrogeomorphology as a study of interaction between hydrological processes and geomorphical ones. In recent years, researchers of hydrogeomorphologies are emphasizing more on explaining the landforms, that is their functions and the process through which the landforms have evolved along with the hydrological conditions. In the year 2010, Malval and Brevard stated the use of hydrogeomorphology in France for demarcating the flooded areas on the basis of topography and geomorphic characteristics of the bottom valley. In 2012, Santos et al. Defined hydrogeomorphology as a science that not only tries to understand the way in which hydrological processes contribute to the molding and the evolution of the landscape, but also the way in which the landforms influence or control hydrological processes at different temporal and spatial scales. The surface and the groundwater influences the formation, development and characteristics of the landforms. In turn, the landforms affect the intensity, magnitude and the duration of hydrological process. To establish the link between hydrology and geomorphology under hydrogeomorphology, centers in 2012 have given three models. These models suggest that a superimposition of a common areas of both hydrology and geomorphology to avoid any interface between them. This is the first model that was given by Santos in 2012. This clearly means that both the sciences, that is hydrology and geomorphology, will use similar methods, but there will be no interaction between them. In his second model, he suggested the crossing between hydrology and geomorphology, which thus becomes the common object for both the sciences. This model was based on the statement which was given by Okunishi in the year 1994 that hydrogeomorphology is a little hydrology and little geomorphology. The third model stated by him considered hydrogeomorphology as an independent branch of science which incorporates both of its own characteristics and elements from hydrology and geomorphology. Now let us study the fundamentals of hydrogeomorphology. The important fundamentals of hydrogeomorphology includes the mechanism and the process. The mechanism gives the explanation by describing the physical and chemical effects, while the process is the simultaneous operation of a set of specific mechanisms over a specific period of time. If you look at the hydrogeomorphological studies, it studies the landforms and the groundwater conditions of the area. So while studying the mechanism and the process in hydrogeomorphology, the morphological and climatic hydrological criteria are considered. The study of mechanism and the process involved help to give the explanation behind morphology and the distribution of the landforms. The second important fundamental concept is the basic tool required. To carry out a study in hydrogeomorphology, it is very important to first design a geographic database including both spatial and non-spatial data requirements with their sources. The most important requirement for the studies in hydrogeomorphology is maps. This includes topographical maps, geological maps of the areas, soil maps, rainfall and climatic distribution map, population density map, groundwater fluctuation map. In India, the sources for these maps are various government agencies and publications like Survey of India of Toposheet maps, National Bureau of Census for population density map, Geological Survey of India for geological maps, India Meteorological Division for climate and rainfall distribution data maps, National Bureau of Soil Survey and Land Use Planning for soil maps, All India Soil Land Use Bureau for land use and land cover maps. Along with the maps, it is also very important to update the data through the satellite data collected and the various national and international remote sensing agencies like Indian Institute of Remote Sensing Agencies in Dehradun and National Remote Sensing Agency in Hyderabad. The third important fundamental of hydrogeomorphology is properties of earth material. Hydrogeomorphologists studies the properties of earth material to get the better understanding of mechanism and the process behind the geomorphic features. They emphasize on the properties of the parent material influencing the formation and the development of landforms along with the hydrological conditions. Type of rock, weathered material, soil, superficial deposit, shear strength, porosity and mineral composition are some of the important properties that hydrogeomorphologists studies during their research. The next important fundamental is the spatial scales of hydrology. Hydrogeomorphology not only studies the effect of hydrological processes on the geological processes, but also analyzes the effect of landforms on hydrology of the area. Thus, the study of scaling effects becomes essential. The spatial scales in hydrology can be distinguished into major three types. The first one is the local scale. On local scale, the parameters like slope angle directly influences the water flow path geometries, flow velocity and the quantity. The second scale is hill slope scale. In hill slope scale is characterized by its runoff production. The soil properties influence the runoff production in the hill slope scale. And the third important scale is the catchment scale. In catchment scale, the morphometry of the basin influences the runoff production. The next important fundamental is the dimensions of hydrological units. Hydrogeomorphological studies the role of dimension of hydrological units in defining the size and dimension of the geological landforms. In India, watersheds are delineated at various levels on the basis of the drainage network. Watershed can be defined as an area of land that includes common set of streams and river draining their water into a single large water body. Water in watershed can come from any of the source. It could be from the precipitation as in form of water or in form of rain or snow or as in groundwater surface runoff. The size of the watershed depends on the size of the stream river and the point of interception of stream or river, the drainage density and its distribution. Now, the next important fundamental is hydrological cycle and the water budget. Hydrology being an important part of hydrogeomorphology, it becomes important for hydrogeomorphologists to study hydrological cycle, water balance and water budget for their research studies. As shown in the present diagram, hydrological cycle refers to the circulation of water into different forms between different spheres of the earth's surface. Hydrological cycle recycles earth water. The hydrological cycle includes inflow, outflow and storage of water at different levels. The inflow adds the water into system while the outflow subtracts the water. Storage helps in the retention of water in the system. If you look at the water budget studies the water availability. It includes the balance between the inflows and outflows of the water. In water or hydrological budget, the inputs are derived from the precipitation, surface water inflow and groundwater inflow, whereas in output factors includes evaporation, combined surface and groundwater outflow and transpiration. Now we are done with the fundamentals of hydrogeomorphology. Now let's see the application of remote sensing in GIS, that is the Geographic Information System, in hydrogeomorphology. To get the better understanding of hydrogeomorphology, it is essential to collect geological, structural and hydrological data of a region. Collection of hydrological data, that is assessing the data of surface and subsurface water resources, requires huge time and manpower. GIS, that is the Geographical Information System, and remote sensing are the platforms through which all the required data can be collected with the better accuracy and time. Remote sensing in GIS carries great importance in hydrological studies as well as in hydrogeomorphological studies. Before looking at the application of remote sensing in GIS in hydrogeomorphological studies, it is important to understand the concept of remote sensing in GIS. It was in the early 1980s the term remote sensing was used for the first time. Remote sensing can be defined as the process of acquiring information through recording devices called sensors about the objects and phenomena without getting in physical contact with them. In remote sensing, the data acquisition is done through different stages. The stages involved in remote sensing or data collection are shown in the present diagram. The important stages include the sources of energy, as you can see in the diagram, transmission of energy from the source of the earth's surface, interaction of energy with the earth's surface features, propagation of reflected energy or emitted energy through atmosphere, detection of reflected and emitted energy by the sensor, conversion of energy and recorded into digital and photographic form, and extraction of information from the data generated. And the final thing is the conversion of information into the map or tabular form. The satellite imageries and aerial photographs are the outputs of the process of remote sensing, passing all the above mentioned stages. Here you can see satellite imagery of Himalayas and northern plains by IRS satellite taken in the May, which is shown in the left, and November, which is shown in the right. The interpretation of the satellite imageries and aerial photographs generated by remote sensing are made through different elements of visual interpretation. If we look at the important visual interpretation elements, then the important elements are tone, texture, size, shape, shadow, pattern and association. In the study of hydrogeomorphology, the same elements of visual interpretation are used to get the interpretation through the interpretation of the images generated by remote sensing of the landforms and the regions covering the water resources. Now, let's look at the concept of GIS. If we talk about GIS, it is a tool of digitally capturing, managing, analyzing and displaying geographic data using computer hardware and software. If we look at the components of GIS, the major components are maps, computer hardware and software, information, procedure and people. GIS is an important tool for geographic studies because it analyzes and answers real-world problems. It makes dynamic maps and displays detailed information about the features in the maps. It not only displays but also studies and establishes relationships between the features. The application of GIS can be seen in studying the relationships, patterns and trends of various spatial and non-spatial elements of the Earth's surfaces. GIS contributes veracity in the study of landform, land use, land cover studies along with the studies associated with water and soil resources. Over the years, due to the rapid increase in population, rapid urbanization and industrialization along with the failure of monsoon has restricted the availability of surface water. Limited availability of surface water has increased the burden on groundwater resources. This has resulted into higher rates of groundwater withdrawal, which further resulting in the depletion of groundwater at alarming rate. For the management and the conservation of the study of groundwater resources, it is very important to use the remote sensing and GIS. Satellite remote sensing has made it easy to study the spatial distribution of groundwater prospects on the basis of geomorphology and other associated features. Satellite remote sensing is also a useful technique for groundwater exploration along with the delineating the hydrogeomorphological units. Groundwater accumulation, infiltration, movement and largely depends on the factors like drainage, geomorphology and slope of the terrain, vegetation, soil, depth of weathering. All these factors can easily be studied using remote sensing at various levels. Remote sensing not only studies hydrological aspects, but it also is an effective tool for geographical structure, geomorphological analysis and the mapping due to synoptic, multispectral and multitemporal capabilities. Geologists largely depends on satellite imageries to collect the data on various lithological units. The important advantages of remote sensing hydrogeomorphological studies can be seen right now. Remote sensing have the access to large areas and even in inaccessible areas it can be used. The aerial photographs and the satellite imageries provide detailed information about the uppermost layer of the Earth's surface, which is essential for hydrogeomorphological studies. If we talk about the digital enhancement, then digital enhancement of satellite imageries improves the level of information which is useful to study the hydrogeomorphology. Data generated by remote sensing provide more accurate and spatial information in comparison to the other hydrological surveys. Through remote sensing, hydrogeomorphological mapping of a terrain and analysis of their processes can also be done easily. This further help in soil resource mapping, groundwater potential zone demarcation, landscapes, ecological planning, hazard mapping and their environmental applications. If we look at the application of geomorphic mapping using remote sensing, then we can also see that it can be used in land use planning and water resource management. The IRS-1C and 1D data of wide angle of WIFS, LIS-3 and PEN sensors are highly useful for geological mapping. The WIFS cameras give the synoptic coverage of large areas and thus it is useful for regional scale mapping and understanding. The finer geological features like the traces of bedding, minor joints can easily be identified through panchromatic data. The panchromatic data provides detailed mapping while the multispectral LIS-3 gives the semi-detailed mapping. Along with remote sensing, in recent years, several techniques have been developed in the field of geographic information system through which hydrogeomorphological studies can be conducted. In recent years, GIS has emerged as a powerful tool in analyzing the various aspects of groundwater occurrence. Groundwater resource of any area is largely controlled by the factors like lithology, structure, geomorphology, slope, drainage, and land use land pattern. All these factors can be studied and analyzed as thematic layers using GIS. This makes it easy to delineate the groundwater prospects and deficient zones. If we look at the main advantages of GIS in hydrogeomorphological studies, then we can see that the large volume of data can be analyzed and integrated using GIS. Also, we can use this data and manipulate and analyze the individual layers of spatial data using the GIS. The rapid, accurate, cost-effective tool it is, and so it can be used for hydrogeomorphological studies. GIS is a powerful tool for generation of hydromorphic mapping and thus it is very important for the study of hydrogeomorphology. Now, after discussing the application of remote sensing GIS in the studies of hydrogeomorphology, now let us study the application of hydrogeomorphology. The Application of hydromorphology can be seen in planning and management of various activities on the Earth's surface. Some of the important applications of hydromorphology can be seen here. The accurate, detailed and timely reliable data on the extent, location and quality of land along with the water resources and climatic characteristics help resource planners in agricultural land use. Data on land potential and conservation requirements through hydrogeomorphological studies helps in improving the quality of land. Hydrogeomorphological studies are found helpful by environmentalists in identifying hazards and studying climatic change. Geologists have also found it very useful in examining the role of surfaces and subsurface flow regimes and the flow paths on fluvial erosion and mass wasting. Ecologists found it useful to describe the linked water between geomorphic conditions that defines habitat in wetlands, rivers and other environments. Watershed management depends on collection and management of information on physical relationships between vegetation, soil and water resources, which can easily be done by hydrogeomorphological studies. Now, after the application of hydrogeomorphology, now let's look at the future of hydrogeomorphology as a geoscience. Over the years, the relationship between the physical and human environment is taking new turns and shapes. The need for the new subfield called hydrogeomorphology stems from the emergence of various challenges resulted from growing human population combined with the effects on the environment and water resource systems. Transformation hydrological cycle, water use, land use and climate is a result of this change in man-environment relationship. In today's era, hydrogeomorphological studies are a great option to manage and control the environmental problems. In recent years, hydrogeomorphology has become an important branch of geosciences to tackle natural hazard impact, environmental auditing, resource assessment and impact assessment. To deal with the new challenges, hydrogeomorphology has developed a close relationship with various fields like ecology, soil sciences and paleogeomorphology. The growth in the importance of hydrogeomorphology as a geoscience can also be seen with the fact that now the world organizations like UNDP, World Bank have also added a clause of understanding the hydrogeomorphology of the areas before stating the development projects into it. Emphasis has been made by these organizations to have a detailed knowledge of landforms, hydrology, materials and the earth surface processes to be utilized or remedial work, planning, framework and land zoning plans. Thus, it can be said that the hydrogeomorphological knowledge is now being utilized in planning and development of the earth as a whole. This shows the growth in the status and responsibility of hydrogeomorphology in recent years as an important field of sciences, as an important field of geosciences. That's all for today. I hope you must have enjoyed this lecture. Thank you so much.